Hey you guys, welcome back to the channel PHYSICSSIRJEE, and here we are in JEE Mains 2021 revision series. If you are new to this channel, this is the series where we will be solving all the previous most debated, intriguing PYQs using multiple methods, and I'll try to put forward the best solutions out of those multiple methods, and we'll try to cover the concepts required for the JEE Mains examinations, especially of the previous year's papers, and also within those previous year's questions we will try to intersperse them with a lot of practice problems from my own versions of those questions which could appear in the future examinations. Okay, so this is a series where we'll be now looking at topic number 2, which is NLM, Newton's laws of motion, friction and circular motion. Okay, so in case you're new to this channel or the series, I would request you to watch the announcement video of this series first, the link of which is in the description below or on the I button above, and where I have told the students why solving the previous year's questions, especially for JEE mains this year, where multiple shifts are going to be getting conducted, and the database of questions is actually going to have repetitions in the concepts, and you'd see that as you solve the questions topic wise, a singular concept or a topic, how many number of times you're going to get it repeated. Okay, so what you're going to not get on this particular video is I'm not going to give you motivational lectures. I'm not going to sing songs. You're not going to get Kabir ke dohe, and I'm not going to do any mimicry or any. I'm not going to crack jokes. The reason being, I'm not that talented. Okay, so this is a very average guy actually going to just produce a video on this average channel. What you're actually going to get is some concept and the subject for the next 45 to 50 problems on NLM and circular motion, which are very, very much important for your JEE main, especially the February shift. With only 30 or 40 days to go, I would call these kind of series as the alpha and omega of your preparation, which is the starting and ending of your preparation. If any student goes into the JEE mains examination without attempting these questions fully and completely, I think that is a half-baked preparation, and he or she would be under real trouble in the exam. Okay, so let's move forward with another important question that always goes through a student's mind in the last leg of his or her JEE mains preparation is what to do with the extra syllabus practice. I've already produced somewhere around 5 to 6 videos on the previous JEE extra syllabus topics. Okay, right? And these were shift wise. I have already done videos on January 2019 and April 2019 and also January 2020 shift papers, where the concepts were discussed in a detailed manner through the PYQs. Okay, right? So the link of this series playlist is also in the description below or the I button above. Please, if you are interested in the extra syllabus topics, this series is a not you should not be missed. Okay, right? So please move ahead and let's start off with the zeal and enthusiasm. Okay, so here's the first question. As I said last time also, the best way to enjoy this series and fine tune your preparation is to pause the video after every question flashes on the screen. Have a scribble pad similar to the scribble pad you will receive in the JEE mains examination. Try to attempt the question within a stipulated time of 30 seconds to 45 seconds, and then go ahead with the solution and the concept that I'm going to explain, and compare your solution with the ones that are going to flash on screen. If it is one or two solutions, try to pick up the concepts for your future attempt of a similar concept. Okay, so with that out of our way, let's move ahead. A particle moving in the xy plane experiences a velocity dependent force F bar is equal to k into Vy I cap plus Vx j cap, where Vx and Vy are x and y components of its velocity. If a bar is the acceleration of the particle, then which of the following statements is true for the particle? Okay, right? So he has given a force, two-dimensional one, and he's talking about which of the following statements is true. Okay, so quantity V cross A is constant in time. F bar arises due to magnetic field. Kinetic energy of the particle is constant in time, and quantity V dot A is constant in time. Okay, so we're supposed to judge the basis of this. Okay, so I think B and C on the first go look the same, right? If F bar arises due to magnetic field and we know that magnetic field doesn't do work, then kinetic energy would have remained constant. Okay, so if you are very smart, you would have said, okay, it's a single option question. B and C, since they are to be similarly or together correct, they may not be options. So that's the first go. You can't guess any more. Okay, so right, maybe A or D is the initial idea. So how to move forward? So let's look at this. This is the way on the left hand side, the usual way of moving forward. If fx and fy are separately written out, as you could clearly understand here, the value of dvx by dt comes out to be proportional to vy, whereas dvx by dt comes out to be proportional to y. Okay, so when you divide the two and integrate, you end up getting that vy square minus vx square comes out to be constant. Okay, so here it's just pretty straightforward integration that you end up having. So once V cross A is taken, because how do you know? I have option A and D to attack. So I'll start with cross product. Okay. So this will come out to be constant. Why didn't I go for option D? It's pretty clear that whenever you have a force whose Vy I cap and Vx j cap is mentioned, if we were to take a component of this particular force along the acceleration, which is what option D is about, right? V dot A, it definitely won't come out to be a constant. Okay, so now let's try to analyze a bit further, right? Why options B and C are wrong. So if these two were to arise with respect to magnetic field or the kinetic energy remaining constant, then F dot V should have been 0. That means A dot V should have been equal to 0. Okay, so in a future question, how could you recognize such a force? Here, instead of giving a plus in between, if you had a minus sign, okay, right? How do you know that? If V bar's dot product has to be 0, this should be a Vy I cap and Vx j cap, so that when you take a dot product with a Vx I cap plus Vy j cap, you should end up getting 0. So this style of force is what would have been produced by magnetic field, and then Ke would have been constant. So not just going through the solution, but I try to understand a future type of equation, how it can be asked. Okay, so I hope you appreciated this. Let's move forward to the next one. So this is a question from September shift of 2020. A small ball of mass m is thrown upward with velocity u from the ground, and the ball experiences a resistive force of mkv square, where v is its speed. The maximum height attained by the ball is. So these style of questions you would see in the next few slides, multiple number of times they get repeated, where they give you a resistive force of either mkv square or mkv or whatever it is, and try to ascertain the height to which it rises, or the time of descent, time of ascent, those kind of style of questions. Here also, if you are very smart, you should be able to guess at least the wrong answers. Okay, so we'll try to move forward, and first let's see the legitimate solution and then come back how you should have approached in the exam. Okay, right. So I hope you have given it a try. Let's move forward. Okay, now the usual solution that you'll get from the internet or textbooks is the one that is printed on the left side. Can you watch it carefully? So when you are throwing a particle up and it's coming down, okay, right? So the value of mg, and mg is a vector, and mkv square are going to act opposite to each other in the downward direction. Okay, right. So when you write the vector form of this particular equation and write acceleration as minus kv square plus g, acceleration as minus of kv square plus g, instead of doing this entire integration and realizing at the end, you could stop here and pause a bit and ask yourself, if a is function of v square from the free body diagram, you could think, should we use a is equal to dv by dt or vdv by dh? Here he has used vdv by dh, right? The reason is, if dv by dt has to be taken and integrated, then you are calculating time calculations, time of ascent. You'll see in the next question where he has repeated the same question with time calculation. So here I have chosen v dv by dh because it is being discussed about height. Okay, so just imagine I were to have a vdv by dh, then you should realize that this kind of an integral, don't perform the integration and waste your time in the exam. Look at the options. This type of integration you should realize is a logarithmic type of an answer. Okay, right? Whereas if I had just written dv by dt here, then I would have got dv divided by v square kind of a function, which would yield a tan inverse type of a calculation. So if time of ascent is there in this situation, I would have got tan inverse, and if height is being asked, I would have got a logarithm. Okay, now which means the two tan inverse options that are given are definitely not the answer in this, and out of these two I have to choose one. Okay, and the best way to choose without doing the integration is by understanding that if resistive force was not there and you have thrown a ball under gravity without resistance, maximum height, we all understand the formula to be u square by 2g. Therefore limit of k tending to 0, k tending to 0 means there is no resistive force, should yield a u square by 2g. It's, you can't just substitute k equal to 0, it's a limit of k tending to 0. So ln of 1 plus x, let's call this as x, divided by x, we all know x tending to 0, you should know, you are better math students than me, so you should be able to use this limit to put it to 1, and tan inverse, you already eliminated a and c, and the limit will eliminate the option b, so because you need the 2 in the denominator. Okay, so that's one way of working through or fun way of getting to the answer, a quicker way. Okay, so let's move forward. Same problem and another shift you could see in the April 2019. This time they have asked the time calculations. You could see the same drag force was given, right? To read the question on your own leisure. So I'm going forward. I think by now you should have guessed that it should be a tan inverse type of a answer. Obviously you can't guess it directly by looking at that. You should have gone through the previous solution up till here and you should have stopped and done all this. Or not take more than 20 to 30 seconds on the scribble pad, and then you realize out of these two tan inverse cases, you have to guess one for the time taken for the ball to rise to the zenith. Zenith means the topmost point. Okay, so I think again you should use tan inverse x divided by x, as x tending to 0 is 1. Tan inverse x divided by x as limit x tending to 0 is 1. And you, I think you know that you need to get v naught divided by g. Time of ascent is v naught divided by g. So based on that, I have written the solution. So these are the four options from which you could eliminate after writing this step. No need to do the integration. You should realize the answer is a tan inverse from here. And there are only two tan inverse answers. And stop here and put gamma tending to 0. Option A will give you the answer. Only option A. Therefore, the answer is A. Okay, I hope you appreciate the alternative way of scoring marks quickly in the exam. This is not guesswork, this is not formula mugging, this is pure intelligence that you need to become the or take advantage over others in the exam, especially when the exam requires time bound calculations. Okay, right. Large number of identical beads, each of mass m and radius r, are strung on a thin, smooth, rigid horizontal rod of length L and are at rest at random positions. The rod is mounted between two rigid supports. Okay, so very famous question, quite often repeated in even local engineering exams of different states. Okay, so you could find it in other state examinations also. The rod is mounted between two rigid supports. If one of the beads is now given a velocity v, the average force experienced by each support after a long time is, assume all collisions are elastic. So this is like a one-dimensional ideal gas kind of a situation where there are collisions and therefore there is an average force experienced by this. But only difference is only one of the balls is given a velocity, not all of them are moving. Okay, so give it a try. Very standard question, and there is a very smart solution for this. Since he's asking average force, you need the concept of head-on collision of, first of all, elastic bodies and identical bodies, that too. So if two identical bodies labeled 1 and 2 for our convenience, okay, 1 and 2 for our convenience, before are going towards each other with v1 and v2, then just before they touch, can you see this is just before, then just after the momentum just gets exchanged. That means one will take the velocity of 2 and 2 will take the velocity of 1. Okay, actually speaking, if these two are indistinguishable, I have labeled them here. Imagine I have erased the label. Okay, so look here on the right of the screen. If I am really removing the label like this, you can't even distinguish which one is 1 and which one is 2. You can actually think that 2 has passed on to the left side and 1 has passed on to the right side. They can be assumed to be passing through each other. without loss of generality if the balls are indistinguishable. So you could assume that in this problem, in order to hit this wall, because balls are indistinguishable, you could assume this ball just passes through all of them, hits and goes and comes back and hits. So it's the motion of only one ball in our mind. Only difference is the distance traveled won't be L anymore, because it will skip the diameter, right? So when someone passes through, then 1 becomes 2 and 2 becomes 1. It skips a diametrical distance. So if n such balls are there, n such diameters would be skipped in traveling that distance. Okay, so that size matters in this case. So therefore, the space between the supports and motion of beads would be L minus n times of the diameter. Diameter is 2r. And the average force therefore experienced would be, for each to and fro motion, there would be a momentum imparted, which is 2 mv. Therefore, average force is momentum imparted to mv divided by the time taken for successive collisions. Time taken is the distance traveled, which is not 2L, it is 2 of L minus this n times diameter divided by V. So that gives you the elastic collision. Okay, so bonus fact in this question, a future question could be made. Imagine, what do you think if X number of balls were moving? Right, capital N number of balls were there, let's say, out of which X balls were given a velocity instead of only one. So I think you should realize that all these balls are passing through each other, so there will be more frequent number of collisions, right? So whatever force you got here due to one, I have to multiply it with X, because each one supplies the same force. So the force will then become X times. Remember, this is how you do it in KTG. In KTG, we assume all are moving. Therefore, the force becomes N times. Okay, that's why pressure is related to the number of moles or number of molecules. Okay, so this is like a extrapolation of the same question. Okay, let's move forward. Another very interesting question, which you should be able to solve through options, and also a nice interesting concept that you can take forward. Particle of mass m is at rest at the origin at time t is equal to 0. It is subjected to a force f of t is equal to f naught into e power minus bt in the x direction. Its speed v of t is depicted by which of the following curves? Okay, so he's given force as a function of time and is asking velocity as a function of time. Okay, pretty straightforward. Okay, if I'll give you the usual solution also. Just look at this on the left side. Your usual solution would be to boringly write f is equal to ma, and then a is dv by dt, and then integrate, and then realize that this is 1 minus e power minus bt, and then go and mark the option. Okay, but it is easy to see that f is equal to 0 is at a equal to 0, right? So if the force becomes 0, then acceleration becomes 0. So you have to check acceleration becomes 0 means velocity becomes constant. So you could see that acceleration can become 0 only at t tending to infinity in this function. So you have to choose that graph where t tending to infinity, the velocity becomes constant. That immediately rules out option A and D. Okay, right. And between B and C, listen carefully to this. You could see that the C option is not perfect, because at t tending to infinity, when acceleration becomes 0, the value of velocity should become a constant. Okay, so that means that constant should be an asymptote to that particular position. Okay, so in that scenario, the answer should be here. The option is wrongly marked. It should be option B is the correct answer. Okay, B is the correct answer. So this one is the correct answer, right? And you can check that one out from here also. You could see at t tending to infinity, it is f naught by mv, right? Let's move forward. This is an assertion and reasoning type question, which is often mistakenly done by the students. 2012 online paper. So he's given two statements, the usual drill that you know, you have to choose which of them is right, and also whether it is a reason or not. If you push on a cart being pulled by a horse so that it does not move, the cart pushes you back with an equal and opposite force. The cart does not move because the force described in statement 1 cancel each other. Okay, right. So if you push on a cart pulled by a horse so that it does not move, the cart pushes you back with an equal and opposite force. So the cart is at rest and it is not able to move because the equal and opposite forces are applied by the cart and you on each other is being said to be the reason, which I feel is not the correct reason out. Okay, so you should realize that According to the Newton's third law, we always keep blabbering that every action is a equal and opposite associated reaction and all that. But you should also realize, you should see the left of the screen, the action and reaction never act on the same body. So when you are applying a force here on the horse, a horse applies the equal force in the opposite direction. You could see the action and reaction are on two different bodies. Okay, right. How this particular thing moves is the force that comes from the friction between the horse and the ground, and also it has to oppose the friction between the cart and the ground. Okay, so if this capital F is larger than this small f, which are acting on two different bodies, has nothing to do with the action and reaction, then only the cart will move. So if at all you are not able to move it, it is because the capital F is not good enough to overcome small f, not because action and reaction are going to cancel with each other. Action and reaction always cancel each other, but they act on two different bodies. Okay, so answer A given in this particular book or text from which I picked the question is wrong. The actual answer obviously should be the statement one is fine. You may not be able to get it out or pull it out. Then in that case, the answer should be statement one is true, and statement true is two is false. Okay, so it should be C. This this is not the reason. Okay, right. He said car does not move because that is not correct. Let's move forward. Again, you could see the repetitions happening across the years, and there are many questions. Because of the length of the video, I could not show you many, right? You can pick any of the previous papers and you could check it out, that concepts are quite repeated. Even at times the numbers and numericals are also repeated. Okay, so we'll take up solution of one of these. Okay, so I'll go ahead with the second one. Let me check which solution I have written down. Okay, right. So a mass of 10 kg is suspended vertically by a rope from the roof. When a horizontal force is applied on the rope at some point, the rope deviated at an angle of 45 degrees at the roof point. If the suspended mass is at equilibrium, the magnitude of force applied is. So here's a question without the diagram. You have to read the question, understand the English, which is the difficult part for most students, and also be able to draw the diagram and then apply some concepts, okay, of free body diagram. Okay, so I hope you have made an attempt. Let's move forward. So he's talking about a thread which is pulled from middle. So initially without the pull, this was straight, and you are pulling it from the middle to the right so that it forms an angle like this. So this is upper part of the thread, this is the lower part, and this is a point of application of a rightward force. This is the external force that you're applying. So it all makes this 45 degree, this is 135, this is 135, this is 90 degree, and stays in equilibrium. Okay, one way of solving the value for the capital F that you're pulling is apply the standard vertical balance of forces and horizontal balance of forces this way and divide and get to it. I'm not saying this is an inferior solution. An alternative and an enriching way to learn the concept when three forces are acting at a equilibrium point is Lami's theorem. Okay, extra knowledge will not hurt, but in some of the cases actually it will give you advantage. So even though here both the solutions are equivalent, it's better we learn this. So in Lami's theorem, when three forces are balancing at a point or equilibrating a point, the magnitude of each force divided by sine of the opposite angle. That means for this capital F, I should take this angle. Whereas for this mg, I should take this entire angle. And for this capital T, the opposite angle is this. It's similar to your sine rule in a triangle. And why is this working out? Because three forces, when they balance, they form a sides of a triangle. So that's why sine rule of your properties of triangle from maths match with the Lami's theorem. Okay. So there is a more challenging practice problem that is there from Pathfinder on Lami's theorem, on which I have made a video, right? So those who are interested in slightly challenging situation, you can check the link of the video in the description below. Okay, so it's an interesting way of solving the problem. Next one, a practice problem on Lami's theorem, or you could use it otherwise, is from 2013 paper, and you could see Lami's theorem will give you answer in one step. Okay, right. So I will not be explaining this. I'll just give you the solution in the next page. So make sure you watch the solution only after giving it an attempt. Okay, so I'm going ahead. Also try to here the usual solution I've given, practice it using Lami's theorem on your own. Let's move forward. This is the challenging problem I was trying to talk about. Link of this video is in the description below or in the I button above. This is a very interesting problem. Okay, it becomes very tough if you use calculus or free body diagrams, but write Lami's theorem, you'll get the answer in one step. Okay, so those who are already following me in this channel would have seen this video. It's one of the best solutions of Newton's laws of motion that is there on this channel. Okay, let's move forward. Next one. An elevator in a building can carry a maximum of 10 persons with average mass of each person being 68 kg. The mass of elevator itself is 920 kg and it moves with a constant speed of 3 meters per second. The frictional force opposing the motion is 6000 Newton. If the elevator is moving up with its full capacity, the power delivered by the motor to the elevator must be at least. Lot of English, but as you are reading on your scribble pad, as you keep drawing the diagram, the picture becomes very clear. Okay, so I hope you have given it an attempt. Let's move forward. It's a pretty simple situation. You would have drawn a simple elevator diagram. You should have read that there is a friction which is a constant value in this. So I'm depicting it for the upward motion in the downward direction. Motion is upward, friction is downward. There are 10 people inside. Capital F is the pulling force of the motor, and the total weight is 10% plus the weight of the box itself. Okay, so this force should be this plus this, because velocity is constant, acceleration is 0. That's what has been written here. Okay, and power of capital F is capital F times V. F dot V, right? Remember F dot V. F dot V in this problem, because these two are parallel, would be simple product of FV. This should give you a simple answer. The difficulty in this question is to solve this in the exam situation. Even for a good student, reading the question, having the patience to read these 7 lines and trusting your concept, you should put pen on paper and start drawing the diagram as you start reading it. That saves a lot of time. Otherwise, 6 or 7 lines you read and you suddenly get lost and you go back and read the question again. That's a big mistake that you can do and waste time on this easy question, and therefore you'll not get time to solve other questions in other subjects. Okay, so very, very careful when you are dealing with such simple questions which are lengthy. Next one, a same vertical motion, right? Things are moving up. You should be able to draw simple diagrams, but only difference in this is that this time the rope that you have between the two blocks which are being pulled up, as you could clearly see, that rope is metal rod here, which has weight. Okay, so this is a case of a rod or a rope having weight. The system is pulled vertically upward by applying a 480 Newton force. The tension at the midpoint of the rod is, again, pretty straightforward. This time you can't equate the forces, unlike last time, where here he has not said that this is moving at constant velocity. So please be careful. So there is an acceleration that could be possible. So I think that should immediately give you the acceleration. First of all, get it, upward force total divided by the total mass of everything that is there. Okay, and the value of that upward force he has taken, and then he's trying to calculate the acceleration and tension at the midpoint. You are supposed to take it up in the question. Okay, there is a problem in this solution because the system is pulled upward, but he has not mentioned any small g here. Okay, so by chance in this question, if small g is mentioned, I don't know whether the book has omitted it or the JEE people. So if small g is mentioned, then you're supposed to take F minus total weight. Okay, so that part is missing here. What's the total weight here? This is actually equivalent to 20 plus 20, 40 kg, which is 400 Newton, right? So there should be a subtraction of 400. So that should change the key actually. So this should be 80 divided by total mass, which is 40. So this will make it a 2 meter per second square. So this will change to 2 meter per second square. That's a mistake there. And this would change to 2 meter per second square. So this would be 16 into 2. I hope I am doing the calculation right. So this is 32 Newton. Okay, so entire concept is same, but the solution in the book, there is a mistake with taking the total force. Total force should be 480 minus weight in the downward direction. Okay, so let's check whether 32 Newton is there. It's not there. So That's what you're supposed to manipulate in the question. So manipulate, don't leave the question saying it will get deleted, right? I'm pretty sure that JE would not have deleted these kind of questions. There are deletions, but not many. So you should realize, even though he is using the word vertically, which is actually wrong by not giving gravity, he has not given that in one of the options. I hope my calculations are right. If anything is going wrong, just let me know in the comments below. Okay, one bonus fact: whether with gravity or without gravity, whenever you are pulling a rod with uniform mass density, you should realize that the tension from one end to another end varies linearly. We'll take up one more problem as we move along to the friction topic also later, where you would be able to realize that the tension varies linearly. I have done recently one video on elastic rod dipped in a liquid, wherein I have demonstrated this in a detailed manner. Okay, so tension in the uniform rod varies linearly. Next one. These are the constraint relation type of problems. Okay, so the connected motion or the constraint motion, which is again, there are not many questions that have been asked. I've surfed through almost all the 8 years papers from 2013. This was the only one question that has come up, but with the database of questions increasing, there is a good chance that this year there could be a good practice of constraint relation. So after this question of PYQ, let's practice some questions, the new questions on constraint relation. So stay back. The machine as shown has two rods, length 1 meter, connected by a pivot at the top. The end of one rod is connected to the floor by a stationary pivot. So this is the fixed pivot, and the other end is connected to a roller that rolls along the floor in a slot. So slot means this cannot move up. Okay, so it has to go straight like this. As the roller goes back and forth, that means this way, it will keep vibrating. The 2 kg weight moves up and down. If the roller is moving towards right with a constant speed in a particular situation, it's moving right, it obviously should go up, right? Up and to the side also. The weight moves up with a, is asking increasing speed, decreasing speed, constant speed, or a speed which is 3 by 4 times of the velocity of this roller. Okay, so 4 very interesting options. I hope you can give it a try on your own, and let's move forward for the concept. Okay, once this is done, we'll take up similar concept questions. Since we don't have so many PYQs on this, I'm going to bring you some new questions at the JEE mains level. So there are multiple ways of solving. This is my way of dealing with this question. Some people will use the length of the rod is also constant, x square plus y square is equal to constant. That kind of relations they can write, but I'm using angle. Okay, right. So if this angle is theta, and please remember that this L and this L are going to have same length at every instant, right? You can't change the length. So this is going to be an isosceles triangle always. Okay, right? So the base is going to be 2L cos theta. If this is L, this is theta, this will be L cos theta, and this will be another L cos theta. That's what I've written. So when I differentiate the both sides with time minus the x by dt, this is straightforward. This is given a constant, right? Because this will be the velocity of this point. Dx by dt would be the velocity of this point towards this direction. Okay, so that's, let's say, is u is given. I'll substitute that in this whenever required. Now, what's the value of y? Y is L sine theta. That also I'll differentiate. That would give me an idea of Vy of this particular point. And please understand, 2 kg will also have an x component, which is not asked in the question. Okay, so I'm only calculating the Vy component of 2 kg. L cos theta d theta by dt. Okay, so dividing these two equations, you could divide these two equations, you'd end up getting Vy is u by 2 cot theta. This entire thing is u. So when you substitute the value of theta, which he gave in this question as 1 meter, this as how much is that? 2 meter, I guess. Okay, so the value of this 2 meter, 1 meter, everything was mentioned in this question, right? So you should be able to 0.4 meter above the ground. Okay, so this is 0.4 meter, and this is 1 meter. You could get the value of sine theta is 2 by 5, cot theta is root 21 by 2. So option 4 is wrong. Option 4, which talks about 3 by 4, is wrong. And you could clearly realize from this expression that cot theta is a decreasing function. So as theta increases, how do you know? When the roller moves to the right, this isosceles triangle, this angle increases. So cot theta decreases, which means the speed of this object decreases. So the answer should be decreasing speed. Okay, right. So that's how you solve these kind of questions. So let's take up a simple or similar practice problem. Okay, I have picked a question with more than one correct type so that we'll have multiple concept covered in a single problem. Okay, so you have a simple pulley block system where block 1 is moving towards right with V, making angles theta and theta 2 as shown. He's going to discuss about what happens to block A. Okay, so this is being moved with constant speed. Increasing speed, decreasing speed. Is it going to move rightwards or leftwards in option C? And the value of that speed is asking in terms of these angles. Okay, so please do give it a try. More than one correct situation. Okay, so here's the solution for it. I have redrawn the diagram here, and I'll be using something called as virtual work method to speed up my calculation. So this is another beautiful method which can involve the problems, especially with threads connected to pulleys and two objects connected to each other using a normal reaction force. These type of questions will deal with this method. Okay, so at our JEE level, actual virtual work method is a huge topic when you go to engineering, but we'll be dealing with only the basic part of it. So net power delivered by the tension is 0 to the two blocks. Okay, net power delivered by the tension. So what is the power delivered? The dot product of force and velocities of these two together when added up should be 0. Okay, so the dot product of these two is tu1 cos theta, and dot product of these two is a negative obtuse angle. Can you see that is minus tv cos theta 2? It should be 0. Tension is non-zero, so it could get cancelled. The value of u, which is the velocity of this object that you need to find, is v times of cos theta 2 into secant theta 1, exactly reverse order of what is given. So this is wrong option. Carefully observe, the option D is not right. Okay, and you also know as this motion happens, this angle increases, right? Theta 1 increases, and it's very clear to your eye that theta 2 should decrease. So if theta 1 increases, secant theta 1 increases, theta 2 decreases, cos theta 2 increases. So overall there is an increase in the RHS. Therefore the value of speed of this object increases. Okay, so you're supposed to mark the two options which we got with an increasing speed, and also it obviously moves towards right, but option D is not right. Let's move for another practice problem. So this time I'll not give you the solution. I hope you can try this one out. This is actually at the JEE advanced level. For those students who have stayed back till now, I should be giving something for them to cheer about. Each one of these questions could be a JEE mains question. So this is a comprehension style of asking the question. So I'll be giving the solution to this in the series that I have running in the channel called as PHYSICSSIRJEE Originals, where I'll be presenting to you some new questions which I have made over the course of last few years for my students. So you can check out the rest of the PHYSICSSIRJEE Originals. Playlist is in the link of the description below, and you can check out, I think, 30 plus nice originals dispersed across the entire physics JEE syllabus, right? So you'll not be disappointed with the level and concepts of those questions. Okay, so let's move forward. So that playlist actually is also accompanied by another playlist that you could go through in the description. We have finished the NLM and constraint motion challenges in this video from the PYQs and the practice problems. We are now going on to the friction. So before I move on, if you want to check out all the NLM and constraint relation type of challenges, I have played a playlist of those things separately. They'll contain both the JEE advanced level and physics Olympiad, and even JEE mains debated questions are there. So you can directly go to that, and you can come back to the video once you can finish those also. So if you want to test yourself on more of NLM and constraint motion challenges, there's a playlist for that separately. I think more than 10 to 15 challenges are there in both the playlists. Okay, right. So let's move forward. So we'll start with friction now. An insect is at the bottom of a hemispherical ditch of radius 1 meter. It crawls up the ditch but starts slipping after it is at a height h from the bottom. If the coefficient of friction between the ground and insect is 0.75, then value of that height h from the bottom of the bowl or the ditch is what? Okay, very standard question. You would see this one repeating across 3 or 4 papers in the last 3 years. Okay, so here's the way to go ahead. There is one way, which is he has done this one here. Okay, so you can consider that insect is actually moving up to different positions. Each position can be drawn a tangent for and thought of as the insect is standing on a inclined plane of variable angle. Okay, so at every place you can define one inclined plane like this. Okay, and we all should know that idea of angle of repose can be used to solve this problem directly. Okay, so which is nothing but saying angle of repose is that angle for which the maximum or limiting friction acts. Okay, so in this scenario, that value of angle of repose can also be defined as the maximum angle of the inclined plane on which a block can be kept up till which the equilibrium can be maintained. If the angle is increased slightly above this theta, then the block slides down, and the value comes out to be tan inverse mu s. So tan inverse mu s is the highest value of the angle of friction, which I have defined in the form of angle of the incline. Okay, so that is your angle of repose. That value should be associated with this mu. Okay, so directly you have been given that it is 3/4, so tan theta has to become 0.75. So you could directly write this step. And what is the height? How can you calculate that height? If this is theta, this should be theta, and therefore the value, this particular triangle tan theta is known to us. Okay, so how much is this height? R into 1 minus cos theta. So if tan theta is 3/4, cos theta is 4/5, you end up getting height as 0.2 meters. Okay, so a very important idea, and the name also, angle of repose. A similar looking problem you could see about the angle of repose, how it is associated, and how quickly you can get to this answer. I'll give you the usual solution also. So let's read it. A rocket is fired vertically from the earth with an acceleration of 2g, where g is the gravitational acceleration, on an inclined plane inside the rocket, making an angle theta with the horizontal. A point object is placed on it. The minimum coefficient of friction, mu minimum, between the mass and the inclined surface such that the mass does not move is. Okay, right? Rocket is moving with 2g in the upward direction. Inside that there is an inclined plane. Okay, I hope you've given it a try. It's a pretty straightforward one. You can draw all this and all, and you realize for a rocket frame, it's like an effective gravity of 3g, right? It's an effective gravity of 3g. Okay, so this should be the 3g cos theta. So printing, a lot of printing mistakes are there. So this is 3 mg sin theta, and the normal reaction would be this. No need of doing all this actually. You could actually argue that in any world, the angle of repose doesn't depend on the gravity. You could see in the previous problem also, when we wrote this equation, this balance, right, to get this tan theta, g gets cancelled on both sides. Whether it is g or a 3g, it would be the same angle of repose of tan inverse mu. Okay, right. So the mu minimum has to be equal to tan theta. So you should have the confidence in the concept of angle of repose to read the question and immediately take this instead of even writing this usual solution that I have on the board. So this is the alternative way of looking at things. Directly, you should be confident enough to write the tan theta by canceling things in your mind instead of putting on paper. Okay, so let's move forward. This is a practice problem that I would like you to do. Same thing again, the insect crawling problem, a variation of that is given here. Your job is to again consider the slope at that particular place. For a hemispherical ball, how you calculated the slope, he'll give you a cross section of a equation, and you know the slope is given by dy by dx. Okay, so I would request you to solve this on your own. Okay, so I've also provided the solution for your support once you are done your work. Okay, angle of repose logic again you could use. So this is like an inclined plane. It's pretty straightforward question. Okay, let's move forward. Right. So this is the recent examination, September 2020, numerical value question. Okay, a block starts moving up an inclined plane of inclination 30 degrees with an initial velocity v0. Okay, it comes back to its initial position with a velocity v0 by 2. So it goes up and comes back, speed is reduced. The value of coefficient of kinetic friction between the block and the inclined plane is close to. Whenever this close to problems are asked, okay, so please be careful. Okay, so it's a caution to leave the problem to the end of the exam. I'm not saying leave that completely. Anytime you see a physics question with close to, either with options or in numerical, you can guess that most of the times the calculation is going to be pretty huge. Okay, so if you are running out of time, it's better to skip such questions and move to another one so that you can score more or attempt more questions. Okay, so right, it's my duty to present to you the solution. So here's the solution. It's a pretty lengthy one, or lengthy looking one at least. It's pretty straightforward actually. When the block goes up, okay, right, the mg sine theta and mu mg cos theta kinetic friction both act downward. So while going up, the deceleration would be g sine theta plus mu g cos theta. Straightforward. Okay, and then you can use v square minus u square is equal to 2as in the upward direction to get the displacement that it moves. Okay, right. So once you get that displacement, then you know while coming down the FBD gets reversed, right? Mg sine theta would be in the downward direction always, but mu mg cos theta will be in the upward direction. So this time the acceleration would be g sine theta minus mu g cos theta, right? Then you get the value of A2. With S already known, the displacement would be same in both the cases. You again use v square minus u square equal to 2as and substitute this time final velocity gave as v by 2. So you should get the value of this. So from here and here, you should be able to directly write. If students are smart enough, they should have written these two steps directly. S is equal to v square by a1. A1 is the acceleration in the upward case, and v square by a2. V square is this time v naught by 2 whole square. Okay, so when you take the ratio of these two, right, you should be able to get the value of mu. And there is no way you could bypass these calculations, right? So root 3 by 5, then you root 3 divided by 5, all this 346. Getting it in 1 or 2 minutes is going to be a challenge for any student. Okay, right. So that's what I wanted to highlight. You will get 2 to 3 questions per subject where calculations are lengthy. Without calculator, it's going to be difficult. Smartness is to push them to the end of the examination. Okay, so here's a method 2 that I am trying to provide. Okay, work, even though this is friction chapter, I think you should open up your mind and think in all possibilities. So work energy theorem is another way, because the body went up and came down, went up and came down, gravity doesn't do work. Okay, and normal reaction anyway doesn't do work. So the overall work is done in the round trip by only kinetic friction, and that should be equal to change in kinetic energy. And work done by friction while going up and while coming down would be minus mu k mg cos theta, because friction force is constant in magnitude, multiplied by 2s. It's the distance travel that matters for work done by friction, not displacement. I think you understand that. Kinetic energy change I substituted. You'll get the value of S is equal to, you already got the S. You have to do the first part. Okay, so in method 1, this part is obvious, you are supposed to write that. So the value I borrowed from b naught square by 2a1. A1 is this thing, and therefore you put this S here and you'll get, okay, I said we get it, it takes time to even and manipulate this number. So method 2 also, yeah, it's slightly better than method 1, but calculation I think you can't avoid. Okay, so that's the not only you learn to both the concepts, but also how to avoid such lengthy looking questions in the exam. Okay, so whenever you say see close to, run up, run away from it. Okay, so for the time being, again similar problems with the time calculations. You could see a repetition from 2005 to 2018, and again it's about the object thrown against an inclined plane. It goes up and comes down, kind of a question. Okay, so he says object takes n times more time to slide 45 degrees down a perfectly smooth inclined plane. Okay, n times more to slide up as compared to slide down. Okay, same logic, you could see slide down. So here's a solution. You know, this time it's a time calculation. Last time it was v square minus u square equal to 2as. So you should know that while going up or while coming down, sorry, this is slightly different. I think not going up and down. You should be very carefully reading it. My bad. He says n times more time to slide down a 45-degree rough inclined plane compared with slide down a perfectly smooth inclined plane. I'm very sorry. Okay, so it is going down, but in two different cases. One is the smooth inclined plane, and second one is the rough inclined plane. In smooth one, it is g sine theta, and in the rough one, it is g sine theta minus mu g cos theta, as I explained in the previous problems FBD. So since in both cases you start from rest, you could say S is half AT square. Therefore, T2 by T1 is inversely proportional to the square root of A's. Okay, so directly you can substitute these values of A and you'll end up getting option as P. Okay, so you could see the repetition there. Again, another practice question. This is just to highlight how many times they repeat the same concept. Okay, so across the papers. That's why PYQs are very, very important. 12th January, again, 2019. He's talking about keeping a block on a rough inclined plane and it remains at rest up to maximum force of 2 Newton down the incline. So when these two are drawn like this, but 2 Newton is one of the cases. When you are applying a force downward, a maximum of 2 Newton ensures that the body still stays at rest. The maximum external force up the incline such that the block does not move is 10 Newton. So the diagram is very misleading. This 2 Newton and 10 Newton are two separate cases for which the block doesn't move. The coefficient of static friction between the block and plane from the given information is, okay? So give it a try and then move forward. So here's the solution. I would say that when you are trying to pull it down, it's easier because you have the aid of gravity. Therefore, the force that is required to go against is mu mg cos theta minus mg sin theta. You need less force, right? Whereas when you're trying to drag it up, you have to oppose both mu mg cos theta and mg. Therefore, there is an addition. Directly, if you can write and visualize this instead of writing all these steps, you can divide these two equations. That's what I have done here, dividing the two equations. So all this nonsense is not required. You can picturize this in the mind. So then you end up getting the value of mu as root 3 by 2. Okay. All right. Let's move forward. A similar looking problem that again repeated in January of 2019, right? Here this time he's asking that if 3 Newton is this way. Last time he gave both the forces, asked the friction. This time he's giving the value of coefficient of friction, one of the force, and asking what should you do in the upward direction. I think pretty straightforward. So I leave this one for your practice and the solution in the next page. A straightforward solution. I've corrected some of the printing errors in the source from which I took this particular question. Okay, so rest of the things I think you can manage. You could see the calculations again. It's not very straightforward, right? It's actually close to. It's not 32 as you can see. Okay, and here he didn't even say close to. So you should be very, very careful with these kind of situations. Trust your concept, trust your calculation. Keep an eye on open. If the answers are very far away from each other, then you should be able to round off also. Don't, if you're not getting exact 32, don't go back and check and waste your time. Your concept should be that thorough. Root 2s are there. It's most of the time obvious that you'll not get a rational number. Okay, right. Let's move forward. A similar practice problem. Body 2 kg slides down with an acceleration of 3 meters per second square on rough inclined plane having a slope of 30 degrees. External force required to take the same body up the incline with the same acceleration. This time he's talking about acceleration. Okay, so draw the FBD, enjoy. One for downward direction and one for upward direction. Okay, so here's the solution for your checking of answer. Okay, all right, let's move forward. And this is a practice problem from my side, slightly challenging one. This time this is a 3-dimensional one. If a block is kept here and you're applying a force actually in a direction which is making an alpha with the horizontal line like this. Okay, so read the question. This is very interesting, and proper conceptual understanding of friction and the inclined plane and the diagram visualization is required to be able to answer this question. Okay, I'll give the solution of this in the AITS select series that runs in this channel. Okay, it's a series where I pick up questions from the past year all India test series of famous institutes. Okay, all the standard institutes that are running their test series programs. I pick questions, the beautiful ones, and I solve them in this series. So you want to check the rest of the questions that I have already done. I think I've done 20 to 25 questions already. So please do go through that series. It's mainly at the JEE advanced level. Okay, right? So the link of that series is in the description below or in the I button above, right? So let's move forward. Comment your answer below so that I can check it. Whenever you're commenting, put a timestamp or a problem number so that I can tell you whether your answer is right or not. Okay, or you can wait for the solution in the next series. Okay, another type of question in friction that is quite famous is the pushing and pulling of the block. Okay, somehow that's a pet kind of a concept that JEE usually both in mains and advanced ask. So if you're pushing or pulling with the same magnitude of force, this is called a push. A person stands here, he pushes it down. A person stands on the right side, he has to pull it up, making an angle 30 degrees with horizontal. In both cases, coefficient of friction is given as 0.2, the difference between the accelerations of the block in each of the cases. Okay, right. uh, I know a lot of you might be saying very easy question, but it's very often that I have seen my students also, very good ones that too, they in the hurry of the exam, they write friction as mu mg cos theta or mu mg. This kind of mugging up will never help. Okay, so draw the free body diagram completely by showing the forces horizontal and vertical directions, and realize the normal reaction is not mg in this problem. So don't ever mug up that friction force is mu mg or mu mg cos theta. It is always, first of all, whether kinetic or static, you have to decide, and then draw the free body diagram. Take your time in the exam to achieve the correct solution. Okay, so this is for the case 1, which is the push, and this is for the case 2, which is the pull. And slightly again, you could see the solution is not pretty straightforward calculation, slightly lengthy. So whenever you see 30 degrees, 45 degrees, close to kind of situations, you should be very, very careful there. Okay, right, let's move forward. Okay, this is a very interesting question. Heavy box is to be dragged along a rough horizontal floor. Okay, so I wish you can read this question on your own and you can solve it. I'll give you the solution of this in the next page. I just wanted to show you the repetition that happens, okay, with the push and pull type of questions. Okay, so this is the solution. Let's move forward. Okay, another favorite type of question is asking about the graph of acceleration versus time when variable force is applied on a block placed on a rough plane. Okay, so it's placed on a time dependent force F equal to KT, horizontal force. Pretty simple this time, where K is a positive constant. Acceleration versus time graph of the block is. So, okay, very standard question, but often repeats in the exam. Block is placed, a force is applied, force keeps increasing with time. Obviously initial stages it will stay at rest, and then it starts moving. And after it starts moving, what kind of graph do you choose? Okay, obviously option C looks wrong, right? Right at the start you won't have an acceleration, so initial acceleration would be 0 for certain period, but it will keep increasing, because once kinetic friction is constant and force keeps increasing, you cannot have a constant. So even D option is ruled out. You are supposed to choose between A and B. If you are ready, I'll go ahead with the solution. So it's going to be a straight line because it's going to be a constant frictional force. So your KT is a linear function minus FK, which is the backward constant value of kinetic friction, divided by M is the acceleration. So it's a linear function that you are having. So linear graph will result in it. Okay, right. So this part of the graph, static friction will act, and this part of the graph, kinetic friction will act, and the value of the acceleration is given by this. This is a KT given, that's why straight line. Okay, right. So here's a practice problem on a similar type, slightly more difficult. This time, instead of having one block and having a KT type of force, I have put two blocks, okay, connected by a thread. Makes it more interesting. And this is quite often a silly mistake is committed by the students in the exam in this type of a question. So again, I picked this one from one of the AITS examinations of the past. Okay, comment your answer below, or just wait for me to give you the solution in the AITS select series. Okay, pretty straightforward, but there is a small trap in this. Most of you would be able to see that trap. especially when you're doing it outside the exam. Inside the exam hall, it's going to be slightly, you should be very careful. Okay, let's move forward. Another inclined plane problem to round it off for a friction. We can move on to circular motion. We are almost at the end of the video now. A body starts from rest on a long inclined plane of slope 45 degree. The coefficient of friction between the body and plane varies as mu is equal to 0.3x. Okay, this time variable friction is given. With the distance it's varying. The body will have maximum speed at what position, right? Where x is the distance traveled from the start. Okay, looks tough, but it isn't. Give it a try, and here we go. So when the block is going down the incline, we all know that mg sine theta and mu mg cos theta fight with each other to produce this acceleration. So whenever the maximum speed happens, you should be able to realize that dv by dt is equal to 0. That's calculus, right? Maxima of the function dv by dt should be 0, which kinematics wise means acceleration should become 0. So this acceleration becomes 0 only when these two are equal to each other. Remember, when these two are equal, we call it as angle of repose kind of a situation, right? Mu is equal to tan theta. And that's what he has done in the solution. The value of mu at that position directly should be equal to tan theta, which is 45 degree. And you will get the answer here. So it's a very simple question, no integration, even though there is a variable friction. So don't run away from the question. Try to think in your mind what he's trying to ask. What does it maximum speed mean? And then your problem becomes very simple. More difficult question would have been in this is the time calculation. There also you have a trick there, how to calculate the time taken for reaching there, right? So there is a SHM trick that I think some of you should be able to explore. Please do comment below in case you have caught that trick. Okay, so let's move forward. Another type of questions are block on block friction problems. Okay, so two blocks A and B, masses MA equal to 1 kg and MB is equal to 3 kg, are kept on the table as shown in the figure. Okay, coefficient of friction between A and B is 0.2 and between B and the surface of the table is also 0.2. Maximum force F that can be applied on B horizontally so that block A does not slide over block B. Okay, so A and B are placed and all the information that is given, always draw this diagram on your scribble pad and write down where the frictions are present. Okay, so that's very, very important for the first step. And also underline which part he's asking, maximum force being asked, so that you can have A sliding over B. A sliding over B. Okay, so here we move forward. The idea is to, like I said, draw the diagram and always write the limiting values of friction. The limiting value of friction, or the maximum static friction force, is mu mg at the top block, and bottom block, please understand, it's mu into m plus m into g. Normal reaction is here due to both the weights. Okay, so that values, if you realize, then since capital A should slide on capital B, right, you should have the value of maximum static friction acting on capital A. Okay, so you cannot have a situation where capital B stays at rest and A moves. That would look like magic, right? You're pulling the bottom block only and that's not moving, but capital A on the top starts moving. That's never possible. So here, if capital A has to slide on B, B already should have started sliding on the floor. Very straightforward, common sense kind of conclusion. So with A and B already moving towards right, you can calculate the acceleration of A plus B system. The value of A plus B system's acceleration would be capital F minus this kinetic friction divided by m plus m. Straightforward. You get the value of that cap A of the together system using capital F. Got this. Then draw the free body diagram of only capital A, on which only force which can provide this acceleration is Fs in the rightward direction. And what's the value of that Fs? Ma it should be. Okay, and this Ma has to be less than or equal to mu mg. Okay, right, if it has to move together. And since you want the maximum value of F, the limiting value will have the equality. That means A should be mu g, and that's what he has written directly in the textbook here. Okay, so this directness came from the analysis that I have done here. Fs should become the limiting value so that the sliding starts. Okay, so he substituted F minus 8 by 4 to that mu g, which is given 2 in this question. Okay, gives you 16 Newton. Let's move forward. And you could see another variation of the block on block. And for the time being, let me caution you or console you that if you are very weak in this block on block type of models, don't worry. Maximum block on block models that they'll ask is only 2 blocks. I have never seen a 3 blocks systems or 4 block systems being explored in the JEE mains or advanced examinations. Okay, so just calm down. It would be not a difficult concept. Once you practice these PYQs and understand the concept, get it done by your mentor, whoever your teacher is. I think you'll all be fine. And these are actually very scoring problems, okay, because a lot of students leave them. Two masses m1 equal to 5 kg and m2 is equal to 10 kg connected by an inextensible string over a frictionless pulley are moving as shown in the figure. The coefficient of friction of horizontal surface is 0.15 and the minimum weight m that should be put on top of m2 is to stop the motion is. Okay, so you're supposed to place something so that the motion can be stopped. Motion can be stopped means it should become in equilibrium. Okay, have a try. Slightly lengthy, but I think you can make out what's happening. Once he's saying stop the motion, I think it's equilibrium condition. You know what this tension should be. Okay, that's a way to move forward. You can, you need not write all this. Whatever he has written all this, right, to increase the length of the solution to scare students away, you need not do that. He has given to stop the motion. Directly realize A is 0. That means this tension should be M1G. Okay, right, like I have written here. And this tension, what that you have here, should be balancing out the maximum static friction force here in the critical case. So if you are very, very clear in your mind, directly you should write this equation of M1G from here should be mu times of m plus m2g. Normal reaction, remember, at the bottom is m plus m2. So it's a very small solution. Actually, the textbook had made it look like a very lengthy one, and I've seen this kind of solutions being given even in other textbooks also. It's not required. You need to just be smart enough to do this, and it's, as you could see, a very simple final answer. Okay, right. I hope you appreciated the way we have done this, and let's move forward to the next style of question, an ambiguous one. Okay, I've already done quite a few ambiguous questions in kinematics. Okay, and dynamics is no dissimilar to that. So whenever you get these ambiguities, don't think that the JEE is going to delete the question. Try to manipulate and think what the examiner meant by that. Go ahead with your answer. Even if the key changes, or let's say it becomes a bonus, you will get the bonus. But if it doesn't, then you should be in a position to score marks there. Okay, so let's see what the ambiguity here is. Block A of mass 4 kg is placed on another block B of mass 5 kg. So block on block, and block B rests on a smooth horizontal table. Good. If the minimum force that can be applied on A so that both blocks move together is 12 Newton, and then the maximum force that can be applied to B for both blocks to move together will be. Okay. I think by now, if you have visualized or drawn the diagram, you should realize the issue with this underlined part. So once you draw the diagram, it should look like this. Diagram was not part of the solution. I've drawn it separately for you. Okay, so he's saying minimum force that can be applied to the stop one so that both the blocks move together. And remember, bottom is smooth. I think that is 0. Minimum force is 0, right? Or anything slightly more than 0, they will move together. What he should have meant here is maximum force. Either textbook has printed it wrong, or the actual JEE paper, which I don't have right now access to, is has given this. But whatever it is, what to do in the exam, you convert this into, obviously 12 Newton, it should be maximum force, and solve the problem. Okay, so I'm converting it to the maximum force condition in the question, and the solution becomes very straightforward. Okay, so as I already told you, in block on block system, always note the limiting frictions at these two places. Here the limiting friction is 0, the smooth surface. Here the limiting friction is mu into 4 into g. Okay, that value is 12 Newton here. Okay, right, and then you can go ahead with the just normal solution. He has given case 1 where you pull that block A, and case 2 where you pull the block B. Okay, right. Another style of friction questions are when vertical surfaces are in contact. Okay, you would see quite a few number of problems on this vertical surface where you'll hold a book against a wall, or two blocks held against each other and one against wall. These type of questions, again, you should be very thorough with your concept of drawing a free body diagram. There's no mugging up here. Even a teacher, when he's teaching this problem, he has to draw a free body diagram, and then go ahead with the solution. Okay, so let's see one question, and I'll give you some nice practice problems on this model also. Okay, so given in the figure are two blocks A and B of weight 20 Newton and 100 Newton respectively. These are being pressed against a wall by a force of F is equal to or whatever force of F. If the coefficient of friction between the blocks is 0.1 and between the block B and the wall is 0.15, so two different friction values. The frictional force applied by the wall on the block B. So he's asking what is the friction here. Okay, so give it a try. Here's a solution. So whenever friction is asked, you should know that you should check whether it is static or kinetic first. Okay, right? The tendency of block B obviously is to go down, right? When if no friction was there, then your F2 from the wall should act upward. Since it is having a tendency to go down, and this A also has a tendency to go down, the friction force on A should act upward. Therefore, the same action reaction should go take it down. So assuming all the blocks are obviously stationary initially, remember that is how you go ahead with any friction problem. Assume everything is stationary, get the values of friction, and then check whether it is under the limiting condition or not. So when you assume the value of the friction comes out to be 20 and 120, but 20 and 120, whether they are providable or not, you have to check. Okay, right? So that checking gives you the value of 120. Here the value of the limiting friction here is 0.1 F and 0.15 F, that you have to take care of. Okay, so the value of small f comes out to be 120 by taking the entire thing as one system. 120 is taken it together. Okay, right. So let's move forward. This is a practice problem. Again, often mistakes are committed on this style of question. This time, instead of taking it up in another series, I'll give you the solution. We'll solve it together. Just give you a better understanding of how to deal with this kind of a situation. So here we move. Two blocks of 15 kg and 25 kg are connected using pulleys as shown. Okay, this is 15, this is 25. Find the minimum value of capital F to hold the system at equilibrium. Coefficient of friction between all contact surfaces here and here, not the pulleys. Pulleys and threads you take in this problem as zero friction. Okay, so how many Newton? There's a printing issue, so I've written the entire options. Okay, again, lot of people actually find this question to be very challenging. They make a silly mistake, they get a wrong answer actually, which is also there in the option. So I implore you to try this one out for 3 minutes and then move forward with the solution I'm going to explain now. Okay, so here we move. So best way to check the tendency of relative motion always, right? Before we draw the free body diagram, you should know in which direction you should draw the free body diagram of friction, right? On these vertical surfaces, whether up or down, especially this 15 and 25 kg in between, should I draw up or down is the dilemma always the students face. The best way is to assume no friction and assume equilibrium, even though both are wrong. Friction exists and this system may not be in equilibrium, right? And look at the mismatched tensions. What does it mean by mismatched tensions? Imagine these things are in equilibrium and there was no friction. This tension has to be equal to the weight. I've taken 250. I'm just assuming. This 250 goes around and makes it 125 and 125. You could see mismatch. This can't stay at rest with 125. That means this 150 will take it down. And that itself tells you the tendency of 15 kg to actually go down and 25 kg to go up. You could start with this side also. You could say, okay, mismatch tensions idea. If this 15 has stayed at rest, this should have been 150, then this should become 300. 300 will pull it up. In both ways, you should realize and conclude 25 kg in this problem has a tendency to move upward and 15 kg is having a tendency to move downward, which is interesting. Heavier object is having a tendency to move up and lighter object is having a tendency to move down. That's the beauty of pulleys. The pulleys get transferred with the tensions becoming double or 2:1 ratio. That ensures this kind of a situation. Okay, with the tendencies already known, now it will be easy to draw the free body diagram. Okay, so let's try the 25 kg on the left hand side. Just follow my lead, don't read the solution on your own, it will be very confusing. The limiting values of the frictions here and here I've written. So remember, normal reaction throughout would be capital F itself that you are applying. So mu times normal reaction 0.4 F and 0.4 F. So both places the limiting value is the same. Okay, right. On 25 kg, 2T acts and it has tendency, remember, to move up, right? Therefore, friction at both the places is down. Okay, and whereas 15 kg has a tendency to move down, therefore friction I have put up with this tension T. And for 25 kg block with these colored forces, 2T should be equal to F1 plus F2 plus 250 in equilibrium condition. But if F1 and F2 are replaced by their largest values called limiting frictions, then RHS becomes greater. Okay, so how do you get from here to here? I put the highest values of F2 here and here, then I'll end up getting less than or equal to. So call this as first equation. Do the similar stuff for 15 kg. I'm not writing the first step. 15 kg, first of all, write the equation and put the highest value of F2. Then wherever you're placing the highest value, that side should be a greater side compared to the other side. So you have this first and second. Now look at this. Here you get T is greater than or equal to some number, and that you substitute here, then 2 of 150 minus 0.4 F. That means I'm substituting this part here should be less than or equal to this. This is where students actually falter. By only looking at one free body diagram, they'll not get the correct answer for the F. So F comes out to be 31.25. Just to comment in the section below, how many of you got, because my students, when they did this question, they got double of this answer, which also is part of the answer, right? 62.5, which is incorrect. Okay, so this is going to be 31.25. Okay, right, let's move forward. Here's the practice problem. A lot of books are held. You could see between the hands, very standard question, famous question asked in one of the AATS. So this is one or more than one correct. Okay, so it's a JEE advanced level question, which tests your concept of this vertical surfaces in contact. Comment your answer below, or you can wait for the AATS select series solution that I'm going to provide within coming days. Okay, let's move forward. Another ambiguous question. Now we have started the circular motion. Okay, so we are left with, I think, 5 to 6 problems. You have been here this far. I would request you to stay till the end. We are going to end the circular motion with very beautiful practice problem. Okay, so let's move forward. A disk rotates about its axis of symmetry in a horizontal plane at a steady rate of 3.5 revolutions per second. A coin placed at a distance of 1.25 centimeters from the axis of rotation remains at rest on the disk. Okay, remains at rest on the disk. The coefficient of friction between coin and the disk is. I hope you had found the ambiguity by now if you have understood the question. Okay, the problem here is you cannot ask directly the coefficient. You should ask minimum value or a maximum value. Okay, that is where the problem happens. If the minimum value is, let's say, some number, any coefficient of friction greater than that also can make it stay at rest. So you can have multiple answer. So then how to resolve the ambiguity? Obviously you should think in a paper with single options, what should the examiner have thought when he has laid down this question? Okay, so that should solve the ambiguity in the exam. So here's the actual solution given in the book, which is, I would say, wrong. Then when the disk is rotating, mu mg force should be balanced by mv square by r, very standard calculations. Only problem is that it is not mu mg that balances it, it is the static friction. That is the problem. Static friction is equal to mr omega square, and this static friction is less than or equal to fs max. Therefore mr omega square is less than or equal to mu mg, so mu should be greater than or equal to this number that you have in the textbook solution, which comes out to be 0.6. So mu greater than or equal to 0.6 ensures 0.6 is not the answer, even 0.7 could be the answer. But as a student, forgiving the examiner for this goof up, I would actually rather mark 0.6 by thinking that he's asking about the maximum value. Okay, so or the minimum value of coefficient of friction. So that's why the option given is D, even though B is also a correct answer. Okay, so this is the problem with this ambiguity and how to answer the question in your favor in the exam. Right, let's move forward. Another straightforward but often asked situation in non-uniform circular motion. Okay, so a point P moves in counterclockwise direction on a circular path as shown in the figure. The movement of P is such that it sweeps out a length of S is equal to distance is TQ plus phi on this arc. Okay, the radius of the path is 20 meter and the acceleration of point P at 2 seconds is nearly. So in non-uniform accelerations, you should realize that there are two components of the acceleration that you are supposed to calculate. One is centripetal, another one is the tangential. Okay, let's move ahead with the concept. Very simple. At that point P on the right side, can you see there should be a essence of tangential component and a centripetal component. Tangential component AT is given by dV by dt, which you can differentiate this one twice and get it 60. Whereas the radial or centripetal acceleration is given by V square by R. So this V, don't be ashamed to actually square it and do it. Okay, so you got both the values, nicely substitute 2 seconds, get some large looking numbers, and resultant acceleration is always given by root of AT square plus AC square. Okay, again, not so straightforward answer as you could see, very close one you have to mark in the options. Okay, right. Okay, next one is on the banking of roads. Okay, this is not a banking question. I'll give you the concept of banking and a very quick shortcut to solve problems on banking if at all they asked in the question. Okay, so the minimum velocity with which a car driver must traverse a flat curve of radius 150 meter and coefficient of 0.6 to avoid skidding is. Okay, are you ready? Okay, so again, a lot of things on the top. There is a solution to the question and we'll talk about the bonus facts below. So first, if the car is actually moving on a horizontal surface, it's the static friction force which will ensure that the centripetal force is provided. Remember, a car moves in a uniform circular motion. Normal reaction upward and mg downward cannot provide the cannot provide the centripetal force towards the center. So it is the static friction from the tires on the floor which is towards the center. A lot of you people will have a doubt, why not behind? Because car is not a box which is sliding. It has wheels. Wheels will turn with v is equal to r omega, such that there is no relative motion between the bottommost point and the floor. So they have the car has a tendency to move radially out. Therefore, friction, static in nature, acts towards the center to keep it in this circular motion. So you should be able to recognize that Fs acts towards the center. Okay, so whenever Fs acts towards the center, that should be equated to mv square by r, and Fs value in limiting condition should be mu mg. That's how when you write mv square by r is less than or equal to mu into m into g and cancel m and rearrange, you get that v max is root of mu rg. Okay, so that's how you substituted. This is when road is not banked. What is meant by banking of road? Banking of a road looks like this. This is a very exaggerated picture where a car is or a automobile is moving on a angled road. Okay, you could see that it's going on an inclined plane. So when you have a straight on view, the car or the block can be, this is not a block, it has got tires, remember. So it's coming towards you, let's suppose, in this picture. Okay, then normal reaction would be like this. And remember, friction again will not act back and forth because of the tires. V is equal to r omega. It is the static friction which could act either down the incline or up the incline, depending on whether it's traveling fast or slow. I have shown it down here, but it could be along the incline like this. Okay, so where is the center of the circular motion? If this object is moving like this, just horizontal circle like this, then the center of the circular motion is here, somewhere here. That direction would be the centripetal direction. And since it is moving in a horizontal circular direction, the upward and downward forces should balance, which is interesting. It's not n equal to mg cos theta. It is the n cos theta that should balance the downward direction of both friction component f sine theta and mg. That's the interesting part here. And also the centripetal force is developed by the components of n and f in this direction, which are n sine theta and f cos theta, which equated to mv square by r. And by putting in these two equations, the limiting value, which is mu s, again, don't mug up. It's not mu s mg cos theta. It's always mu s into n. Then you end up getting this expression, and substituting it back, we get V max is equal to this when the car has a maximum value. And similarly, when it is having a lesser value, it has a tendency to actually fall down. Then Fs will act up the incline. Okay, and you can go ahead and do the calculation and you end up getting this. These two are very bulky looking formulae, but you can remember it in a straightforward manner by remembering angle of repose. Mu s can be written as tan phi, right? Phi is the angle of repose from that back problems that I have just now discussed. Okay, so when you put tan phi here and here, this is actually tan a plus b formula. So here also it is tan A minus B. You can remember the angle of banking angle and the friction angle. Both are associated with the range of velocities with which a car should move in a radius of r, horizontal radius of r. So this is a pretty straightforward relation that you get instead of this bulky looking µs. So tan of theta minus phi decides the minimum value of speed, and tan of theta plus phi decides the maximum value of the speed. Okay, very interesting, right? And I think I could say that this theta equal to 0 by sandwich theorem is the limit of these two actually merging to single value. When you see the value of the theta is 0, when you substitute theta is 0, both this limiting value become this root mu rg, because you'll get tan phi. I'll replace it with mu s. That is how you got this. Okay, so we discussed that, and this is the special case I was talking about. When mu is 0, that is tan phi is 0. What is mu 0? You have a banking angle, that means inclined plane is there, but friction is not there. Then you have to put phi is equal to 0 in both, then root rg tan theta. If theta is 0, what does theta equal to 0 mean? The flat surface, but friction exists, then you have v is less than or equal to mu rg. So whenever friction is there, you'll always get a range, and when friction is not there, you have only single velocity. Okay, right. I hope you appreciate this. Let's move forward quickly. And the banking type of problems can be virtually asked in a different style of situations like this, but the solution would be similar. So a bead of mass m stays at a point a comma b on a wire bent in shape of a parabola, some curve he has given, and rotating with an angular velocity. So instead of car rotating around, you can have the road rotating around like this. And this is similar to your angle of banking kind of a situation, because there is no friction. This is going to be zero friction, but angle theta. Only difference is this is a variable angle, right? So at that place, you need to get the tangent. Okay, so here's the solution. This is a bulky looking solution, but I think you can borrow this one into this and think that the car is actually going around with respect to this rotating frame, and with the radius x and n m x this thing, and you can directly write root rg tan theta. Root rg tan theta. You could see that. Okay, using Lami's theorem, you can directly see the value of velocity is root rg tan theta. So directly you can write the omega if you can. Okay, so straightforward. Again, another similar situation where a smooth wire of length 2 pi r is bent into a circle and kept in a vertical plane. So this is a wire in vertical plane. A bead can slide smoothly on the wire when the circle is rotating with an angular speed omega about the vertical diameter AB, as shown in the figure. The bead is at rest with respect to the circular ring at position P as shown. So the bead is at rest. This is turning like this, okay, right? Because this entire thing, this entire circle is rotated in a vertical plane about this diameter. Okay, so the bead goes in a smaller radius depicted by r by 2. The value of omega square is how much? Again, zero friction problem. I think you should be able to directly write this as the car going in an inclined plane, which is given by a tangent here. Okay, right? I'll show you the usual solution and angle of banking idea. So usual solution is this. You will try to write n is this way, mg is this way. You require a centripetal force and do all this honest thing. But an alternative outlook would be, at this place there is an inclined plane. This is like a car going around an banked road. Root rg tan theta is the value of the v. V can be written as r by 2 omega. Remember, it's a circle of radius r by 2. Capital R is also r by 2. Theta that you can find out is 30 degrees, right? That's why tan theta is substitute as 1 by root 3. With this, you can directly go to this. Again, don't mug it up. If you are honest, you can do this also in a very quicker manner, but you could alternatively see and praise that there is a situation similarity between this and the banking of roads. Okay, right. Always read carefully whether friction exists or not in the question. That's the simplest thing that you should do. Okay, another rotational problem, circular motion. A spring mass system M and K, natural length L, rests in an equilibrium on a horizontal disk. The free end of the spring is fixed at the center of the disk. If the disk together with the spring mass system rotates about its axis with an angular velocity omega, the relative change in the length of the spring is best given by. So this option is very, very important here. K is very large compared to the value m omega square. Okay, so recently asked question, 2020 paper. Draw the diagram. I think you should be fine with this question. Okay, so here's the solution with that. So once you are rotating and it stays at a extended position, let's say that extension is given by x, then the value of L naught plus x, this should be L naught. Okay, so L naught plus x, the centrifugal force of m into r omega square, m r omega square, r is L naught plus x, please be careful, should be equal to spring force, which is kx. Okay, so this rearrangement, this you get, since k minus omega square is approximately k, you should be able to rearrange and get to this answer. Relative change is given by the change divided by original length. Relative change, he asked. Relative means always a fractional change. Fractional change is change in length divided by original length, gives you this number. Okay, a same question you could see a repetition in 2020 paper. This time that k very large is not given. I think you should be able to practice or recognize this question again. Okay, so very interesting that they repeated it twice within the same year. Can you think of a logical substitution to arrive at the answer? Let's suppose you don't want to solve this question. It doesn't take much time to solve, but imagine you are in the last 15-20 seconds and you want to guess the answer. Look at the dimensions, units, some substitutions. Can you arrive at the answer? Just comment below what you would have done to guess the answer. Educative guess. We're not doing it by fluke. There should be a logical substitution that you can think of to come to the final solution. Okay, so I will be eagerly waiting for your comment on this question. Last one, we have reached the end of the video finally, and please do stay back. I'm going to announce the next topic. Okay, so here's the last question for your practice, slightly again tougher one, more than one correct type. I'll give you the solution of this in AIT select series. You can also comment your answer below. I'll tell you whether it's right or wrong. Okay, so here we move forward. So check out the rest of the friction and circular motion challenges if you want slightly more interesting and JEE advanced and physics Olympiad level. The playlists are given just like your Newton's laws of motion playlists. Okay, so that's one thing out of our way. And what is your next topic you want? Okay, so we have already done kinematics. We have done Newton's laws of motion, friction and circular motion now. So usual logic would tell you that I should go ahead with work energy power. So in the sequence, is that the option one? Or should we go ahead with some of the heavyweight topics, the topics which have obscure type of questions, tough questions, more weightage questions? So I pick a topic called as heat and thermodynamics, huge number of repetitions, and but also ambiguities and a lot of conceptual clarity is lacking in the topics given in the NCERT, especially exemplar problems. So those type of questions are asked. So that's one topic. Electrostatics is another topic which is huge. A lot of scope is there. Okay, so which one of these three I should put my effort into? You just should be able to vote. Okay, so how do you vote? Comment community tab, I have created a poll giving these three topics as the options. Just vote, and once the next topic, whichever of you these three reach 500 votes, I'll be then only taking the next topic. I don't want to put my effort into something which is not reaching students. So try to spread this particular series to as many students as possible so that I get enough motivation, right, to continue with this work. So because I am also doing other series in this particular channel, so that and my time has to go there also. So please make sure one of the three topics. Okay, so that in the next 5 days I can start making the series video on any one of these three. Okay, so those who can't vote, they can comment below. So I'll take the votes and also number of comments on these topics, count them, and if once it reaches 500, I'll upload the next topic video. Okay, so not only this, as I keep saying, the JEE Mains revision series, there are other important series if you're new to this channel that are running parallelly in this particular section. Okay, so go to the description below, spend some time, go through each of these links that I have given for these respective series. Okay, so descriptions of these series are given in their playlists, and you should be able to go ahead and enjoy these, right? So if you're new, I would request each series you can go ahead and watch 2 or 3 videos per day. Please watch them in the order of uploading. That means the first video that uploaded, watch it first and then move forward, because there is kind of a continuity in the way I produce the problems. So it's not like one problem, one video, and I don't see it. Okay, I will keep invoking the concepts that were taught in the previous video. So there's a continuity, a thread going on, 170 odd videos. So the best way is to start from the first video, go to the video section of the channel and start enjoying. Okay, so and I hope after 3 or 4 videos you would be able to subscribe to my channel in case you haven't done it. So please do like this video, try to spread it as much much as possible. YouTube algorithm spreads the liked videos more and recommends them to higher number of students. Share it in WhatsApp and Telegram groups. Request the students to come and vote. Watch this video, and I would say this is one of the best preparations for your JEE mains. Okay, without doing your PYQs and trying to understand the concept around it. It's not just doing PYQ, but trying to understand the concept around the topics. So you'll understand once we move into even tougher topics like nuclear physics, modern physics, then electrostatics, heat and thermodynamics. You'll understand this preparation is the best way to move into the exam. Okay, so I hope you'll support me. You have been supporting me and loving me a lot. It means a lot to me, and keep doing that. And I'll keep coming up with quality content that I'm known for. Okay, so thanks for staying this long, and see you.